Hello there, it's Jay here from Jay's Vintage Junk, and if you haven't guessed already, yeah, we're finally going to have a play with this Amstrad. I picked this up, I think it was last year I picked this up, and I got it at quite a reasonable price. These Amstrads are now selling for silly daft money, far more than I'm normally prepared to pay for the junk that I like playing with. But like I said, I managed to get this one at quite a reasonable price for two reasons. First reason was it was collect only, so I had to take a little drive up to Warrington, which isn't that far away from me, but it's a little drive up the motorway to pick it up. The second thing was, well, three things really, I suppose. The second thing was apparently it's dead, as in the seller tried plugging it in and there is no signs of life at all with it. Third reason was it didn't have a keyboard. Now, if you're not familiar with the Amstrad PCs, although they are IBM compatible PCs, they'll run all your IBM software and everything. The one thing that isn't IBM compatible is actually the keyboards. This goes back to the fact that on the original IBM PCs, on the original IBM XT and the original IBM 80, one of the few things that IBM actually copyrighted was the way that the keyboard is implemented. Now, just about every other clone manufacturer basically just ignored that, and I think either said sue me or paid something to IBM to use their code or their way of implementation of doing it. Amstrad went a different route and basically just designed their own keyboard interface. So basically the Amstrad machines need an Amstrad keyboard to work with them. That's one thing. This keyboard is not the keyboard for this computer. This is actually the keyboard for a later Amstrad. This is for an Amstrad 4000 series. This is an Amstrad 2000 series. But I'm not 100% sure on this. I'm guessing, I am hoping. The connector actually, which is not the same as a standard 5-pin DIN. In fact, I've got one kicking about around here. I think I might have put them all away, unfortunately. Yeah, these are all PS2. But basically the actual DIN plug on the Amstrad, I don't know if you can make that out on the camera. Can I make that out there? Let's see. If you actually look, the pin spacing is different on the Amstrad 5-pin to a standard AT 5-pin keyboard connector. That isn't the, like I said, that is not the only difference. The protocol is actually completely different. What I'm hoping though is that Amstrad kept that same protocol, you know, between the 2000 series, the 3000 series, the 4000 series. Now on the 5000 series, they actually went to just use the standard IBM protocol. So if you've got a keyboard from a 5000, they're actually really nice keyboards if you can find a keyboard from a 5000 series. Because you've got a standard AT connector, but they're ATXD switchable. Because you still could get an XT version of the 5000 series machines, and all they did was use the same keyboard and put an XT80 switch on the back of it. The 2000, 3000 and 4000, I'm not even sure if there's an XT version of the 4000, but there's definitely an XT version of the PC2000 and PC3000. They actually use a different connector. Although the keyboard looks the same as the 2000 keyboard, as in it's a bigger version of this, you know, it's a slightly bigger keyboard. It actually uses a completely different connector. I'm not sure it isn't the same connector as the Amstrad 1000 series, which was the PC1512 and 1640. I'm not sure if you can actually use that keyboard on them, because those are all XT class machines. Anyway, before we can even get that far and see whether this keyboard is going to work on this computer, we need to see if we can get this computer to work. So what I thought we'd do, this is probably not all going to get done in one video, but what we're going to do, we'll crack into this. I've never even taken the lid off this, I don't think. I'm not sure if I took the lid off and had a quick squeak inside it, but if I have, it's certainly a long time ago and I can't actually remember what we've got in here. But we've got basically an IBM PC2286 40, so it should have a 40 megabyte hard drive. It's 12 megahertz 286 processor, and I think these shipped with 1 megabyte of RAM. But interestingly enough, this is one of the few 286s that I know of that you can actually do this. You can put 4 meg 30-pin SIMs in here. It has 4 standard SIM slots, so I think it ships with like 4 256k SIMs to give us you 1 megabyte. You could pull them out and put 4 1 megabyte SIMs and take this up to 4 megabytes, but apparently, and we might be able to try it if I've got any. I'm not sure if I've got any 4 meg 30-pin SIMs or not. I've definitely got 1 megabyte ones, but apparently if you put 4 megabyte 30-pin in here, this will actually support up to 16 megs of RAM, which I know is basically what's technically possible on an AT, on a 286, but most you'll find will have like 1 megabyte on board, or perhaps up to like 5 megabytes on board, and if you wanted to go further than that, you had to use RAM expansion cards. So I mean, this thing could be like super expandable. Anyway, before we can do anything else, like I said, it does not do anything. You can plug it in, switch on, and no signs of life at all. So first thing we'll do, let's start at the plug and we'll work our way round to the outputs from the power supply. So first thing we want to do, let's have a look in the plug and let's just make sure the fuse is good in here. So what have we got? It's actually not wired too bad. The live there could do with being a little bit shorter, a little bit exposed. Oh, that's not good. The earth is actually loose. The earth is just broken off. Right, yeah, so we'll have to rewire the plug. Fuse. What have we got in there? I think that's we've got a 5 amp fuse, and that's an oldie. Marbo. That's an old fuse. Let me just do something about that earth there. I think it's easy enough to do right now. Let's just see if we've got enough. That's why it's broken off, actually. There isn't enough strain relief on the earth there. I'll just see if I can just push it up and make it reconnect for now. I mean, obviously it would work without it, but let's be as safe as we can do, shall we? I think we'll get that in there for the time being. And we will have to rewire that plug because the wire's not really long enough. Push that in there now. There should be just enough in there for me to make that to connect. Yeah, it's biting down. Right, so that's okay. Let's check. At least we're all connected back up there. Let's check that fuse. Now, even this fuse is blown, we're not going to just change the fuse, plug it in and try it, because these fuses don't blow for fun, they blow for a reason. Right. Yeah, that fuse is absolutely fine, so we've not got an issue there. We've got power, we know we've got power through that fuse. The other interesting thing with these Amstrads, they actually have a power cable hardwired on. So you don't have the normal IEC connection on the back where you can just change the power lead. The power lead is actually hardwired into the computer. I know it's not the only one, because I have seen a couple of other computers done like that, but it's certainly not not normal. Right, let us delve a little bit further into here. Get the screw off. Let's get the back panel off. Let's see what we've got. Let me see if I can get this up slightly so you can you see what's in here? Right. Or am I going to have to get you? I'll tell you what, I'll get you over the top of me and we can kind of like look down on it. So let me get the camera repositioned and we'll look down properly. You can actually see as I take the top off and everything. We can have a good look inside here. So back in a... Right, okay, there we go. I've done a bit of repositioning. I've got it on the workbench so you can actually see it a bit better now. Right, let me have a quick slurp of coffee. And I think what we've got to do, basically, we've got to take the cards out of it before we can even split the computer, because these long screws here, well, these screws here, they're long, they go all the way through like that, and they actually hold part of the case together. So I think first things first, we'll get them out. And then I've just noticed some rather nasty corrosion inside the computer, which doesn't look very good. Which is the one thing I was really hoping with this computer we wouldn't have. The simple fact that the batteries live up here. And it's pretty obvious when you're looking at these if they've got corroded batteries, because obviously you can see the remnants of damage on here and staining and stuff. And that looks pristine on this computer. But then you've got, how many years did this spend in a garage or a shed or something like that, which might be the reason why it's looking a little bit icky down in the bottom there. But anyway, never mind. Like I said, at least we've not got any major battery corrosion, which was one of the reasons why I rather wanted one of these. Well, let's pull the first card out and see what we've got. In fact, that's quite a nice card really, for one reason. In fact, let me put my anti-static on, so we're going to be handling cards. What we've got here first, I'm pretty sure this was used in, you know, a school, an office, something like that, because this was networked. Nice also that we've got some information here. We've got a Type 17 hard disk and the batteries were replaced 20th 10th 97. So this thing had a fairly long working life. If it had its batteries changed in 97, so it was still up in use then. I wonder exactly how long it was this thing had a useful service life. Right, so we've got a Novell network adapter here, so it'll be something like an NE2000. Might even be earlier than NE2000. All it tells us is Novell Inc. 1990. We've got a 2-bit T connector and a token ring connector there. I think that's token ring, isn't it? That's definitely 2-base T, because I used to use that myself for my network back in the day. Not the most useful card nowadays, apart from one thing, and that's that hole there. Basically, that will take a boot ROM. The XTIDE boot ROM, which basically allows you to use a lot of hard drives, IDE hard drives on these older systems that wouldn't normally support them. You can put the XTIDE boot ROM in, and it'll, like I say, it'll allow you to use much more larger, more modern IDE hard drives. No matter what controller you're using, whether you're using like a plug-in XTIDE, whether you're using just a standard 16-bit IDE card or something like that, that ROM will allow, like I said, you'd be able to plug pretty much any hard drive in it, configure it and work with it, even if the computer wasn't originally designed for it. And you can actually use an old network card to boot one of them ROMs, because these have the ability to boot from ROM. That's how like the Novell networks basically used to work, as in it would find the server and everything using the boot ROM on the actual card. It doesn't have to be a network boot ROM. Any boot ROM will work, like I said. So we can put the XT IDE boot ROM in there, configure it, put it in this computer, and it will give the computer that XT IDE compatibility with hard drives. So that is kind of useful, even if it's just for that purpose. No one really uses 2BASE-T anymore, and I know at least one person online that's messed about with that, and it's very interesting. It's quite nifty and nice, but it's a lot of work, and the parts and the stuff for it are not readily available. I've got a few bits and bats, but I don't have anything like from the back end, like a hub or anything to connect them to. Anyway, so right, we've got a nice Novell network card there, and now this is interesting. What we've got next, because this is not what I was expecting. We've got a hard drive controller next, which I was expecting, but not what we've got in here. Let's get this out. Another of them long screws. Now it looks like here we've got, yeah, an IDE. Let me see if I can disconnect it. Yeah, because there's virtually nothing on this card. It's Miniscribe Corporation, and we've got one 40-pin header there. It's a 16-bit card, but that'd make me think IDE. Now, I was always led to believe, and from all the documentation and online that I've been looking with these, that the PC2286/40 was fitted with a 40 megabyte RLL hard drive from the factory. Apparently, they was intending to actually use an onboard hard drive controller in these, and then for some reason at the last minute, either they couldn't get it to work right, or there was some incompatibility or something, and they apparently just went with a standard RLL controller and a 40 megabyte RLL hard drive. I'm wondering whether that must have failed on this and someone has upgraded it, so that kind of makes us wonder what size hard drive we've got in this, because that ain't RLL. That most certainly looks like IDE. Anyway, I'll put that to one side. Again, looks in reasonably decent condition. It looks very clean. No corrosion on any of the edge connector down there. Right, now we are a little bit closer to actually getting inside this thing. That might be as far as we get in this video, we don't know yet. The intent of this video basically is to get down to that power supply, because we know we've got an issue somewhere with the power supply. It could be as simple as a bad switch, it could be a completely fried power supply, because I have also looked online and I have heard this doesn't bode too well either. And we see the, let me see if I can hold them up to you so you can see them. Can you see the corrosion on them screws there? So at some point this has definitely been somewhere that's been damp, and it's been, you know, not well looked after at some point in its life. And we've got some corrosion on that bit of shielding there as well. That's one seriously heavy duty back blanking plate. They don't make blanking plates like that anymore. Dear me. Like over a mil thick, that. But there was only the one, so this obviously may have had all the cards in it which have been removed. Right, that's free now. So we've got a screw there, and then two at the front here under covers. Let's get them covers off and see what those are like. try as careful as I can. I don't want to break any of these little bits of plastic, because I don't think I'll have much luck finding replacements nowadays, and the plastic obviously on this is getting yellowed and brittle, and like they all do. That's the only problem with these Amstrads, because they all use plastic cases. It's the same with my apricot, because that used a plastic case, and the cases just go yellow and get very brittle over time. Right, quick slurp of the coffee. I've got 2 more screws, and I think we can split this in half. That's that one there. I think this is the last screw. I think after this one we should be able to get inside it and have a good look. Right, let us see. That's free there. Oh, we've got to ping that off. There we are. And we're up. Right. I'll disconnect the battery hook connectors there so we can take the top of the case off. Okie dokie. We're in. Right, so that there is our power supply. That's our first port of call. That's what we want to have a look at, because I have a feeling that's where our issues are going to lie. So let's see how we disconnect this. Oh, that's interesting. You know what, I think we might be able to get the board at least to power, even if this power supply is completely dead and we can't do anything with it in this video. I think we might be able to get the rest of the computer to power up, just having a quick look at something. Anyway, what I'll do, we'll get this power supply out now, because then we can actually see the rest of the main board in there. And we can have a look. First of all, we can have a look, see at this power supply, and we can have a look, see if there's anything we can do to get this working. Let's have a look here. I don't actually think anyone's really been in here messing before me. There's what looks like plaster dust or something. I think that's what that ick at the back is. Yeah, it's dust rather than corrosion or anything. So this must have been in, you know, a cellar or an attic or something like that. Come on out. The cable might... Oh right, that's why. It's actually twisted all the way around. Let's get this screw out. Lift that up and out. Let's have a look at this wire. Oh, I like this. So, to disconnect, we can just... Okay. The way that the power distribution is done on this is a bit weird, I'll say that straight away. Perhaps it won't be as easy to power up as I initially thought. So we can disconnect that like that. And I was seeing that there and I thought, oh, is that just a standard like Molex style connector going straight onto the board? And yes it is, but it's not the only one. So we've got that one disconnected, that disconnected. We've got another power connector there going down, that's disconnected. Essentially, like I said, what I want to do is extract this power supply, and then we can work on the power supply get that working, or at least find out whether we can put something else in its place. Where's that one going? That's the hard drive. So we can disconnect that. That's the hard drive, and all we've got left is the floppy over there. Disconnect that. Pull that through. Right, lovely. I think we're good there. I think we've got everything disconnected power wise from the main board. Let's let that screw out. And you can get the, I'm hoping all this comes out in one, you see, and then I can work on it just as a standalone unit. That's out. Dear me. Yeah, I don't think anyone's really been in this much in the past. These screws feel very very tight. I think I might be the first person to remove them since it was put together. Okie dokie. Right, I don't know if I had to get that one out or not. Let's just see if we can get this power supply to release. Right, so we've got the button there. Does that come out with it? Oh, there's another screw. I've missed a screw. Another tiny little screw down that. There we are, we're out. Lovely. There we go. That's the power supply removed. Right. Ooh, and that's sticking horrible underneath. What I'll do just for the moment, let me get all this out of the way, and we will have a quick look at the power supply, see if there's anything we can do with that. If not, well, let's see if we can get the voltages we need and get power to this. Fortunately, with the size of it, if this is completely dead, I can't see any issue with me basically put something else in this case. With the way that the switch and everything works, we should be able to work around that. But let's see if we can get that working first. I'll get all this out of the way. We'll get that just on the bench, and we'll take it from there. So back in a sec. Right, okay, we are back. As you can see, I've got everything else cleared away for now. So let's concentrate on this power supply and see if we can get some life out of it. So let's have a look here. So we've got actually quite a sticky, by the feel of it, main switch. That does feel like it's sticking a bit. And we've got all our outputs there. It does go without saying, obviously we've got mains in here. If you don't know what you're doing, perhaps best not mess inside switch mode power supplies. I've been working on these since I was considerably younger than I am now, and I'm still here, but like I said, I have worked on them for a very long time. I mean, not exactly a thing to cut your teeth on, put it that way. There are certain capacitors in here which can potentially hold a charge for quite a considerable amount of time. People do actually make out that they are a bit more dangerous than they are. They're unlikely to kill you unless you've actually got a heart condition or a pacemaker or something like that. But you stick your finger across one, I can guarantee you know about it. Right, let us see if we can get in here. Okay, so far so good. Am I missing any screws? There we go. Ooh, so, right, come on, off you come. There we go, out. There we go. We're off, we're in. That's a dirty one. That's dusty in there. Right. Are you going to release and let us out? So we've got it to play with properly. There we go. And off you come. Right, that's the top out of the way. Okie dokie. Let's have a look what we've got in here now. I can see, oh dear, oh. I can see liquid all over this board, which doesn't bode well. We've got our mains input there, but I'm looking down here and I can see all kinds of liquid underneath these capacitors. That's our main switching transformer there. That's our mains isolation. That's our main DC smoother. That's the one that can pack a little bit of a wallop and give you a bit of a bite. But I can see already we've definitely got issues in the low voltage side here, because I can see like physical leak, literally goo all over the PCB there. So let's go a little bit further. Let's delve a little bit deeper in here. Let's get Mr. Cable Tie there off. There we go. We can disconnect the fan. That's the fan disconnect. Oh God. Yeah, I think we've got some major capacitor leakage in this one. Right, let's get this board out. So I'm already starting to get a slight whiff of fish straight away, and I've not even supplied any heat to it yet. Yeah, this is horrible. This is really bad. A big switching module there. Now if that's faulty, that could spell end for this power supply. Because the likelihood of getting a replacement for that's not going to be high. We could be really lucky with this thing and just find out we've got bad electrolytics and possibly like a blown fuse or something like that, but it's not looking too good. Right, okay. That's all the screws out. Should be able to pull that out from the oh yeah, oh this is disgusting. You notice how wet the entire PCB is there. The whole thing's, I don't really want to touch it with my hand. Let me see if I can find the Q-tip. There they are. The whole board. Yeah, I can see that. Let me get that up so you can see it. All that there, that's capacitor juice. The entire bottom of the board is absolutely covered in capacitor juice. Then we can check that it is that straight away. Let me just get my soldering iron and give a quick. Oh God, yeah, that's definitely capacitor juice. Bad fish as soon as you warm it up like that. The whole board is absolutely covered. I mean, really covered. There's some other little bits of corrosion on there, but not bad. Most of it is all this leakage, all over here, all around here, all around here, all, yeah. That's leaked really bad. Let's see if the mains fuse is still intact. Because if that's blown, that's probably an indication of why we weren't getting any any power. No, so our mains fuse is still intact. So we've probably still got power onto that side of the board. In fact, let's just check the switch to make sure that the switch is working. Nothing on that side. Nothing there. Let's switch the switch in. That's alright. Yeah, so our switch is working, our fuse is good. The problem is with all that electrolyte around there, and if that's conductive, it's shorted half the board out. This is going to be a lot of fun to see if we can get this working. The only good thing is it is just a switch mode power supply. If we can't get it working, the voltages that come out of it are all dead standard. We've got what? We've got 5 volts, 12 volts, and then we've got a few extras on there. We've got our usual, we've got a minus 5 volts, minus 12 volts. We've got a minus 5, we've got a minus 12 volts, plus 12 volts. We'll have a power good line, which I think is usually the white one. It might even all be marked on the board here. Yeah, it looks like they are. Yeah, they're all marked on the board, so if we can't fix this power supply, it's going to be easy enough to substitute something into that case that's going to be able to do exactly the same job as these, but the biggest problem is going to be cleaning all this leaked electrolyte off the board, because it is really, really, really bad indeed. In fact, there's no time like the present. We might as well just get on with it. There's nothing I can really do with it in this state. Let's get the old PCB cleaner. Get some of that on there. I suppose we better just start with the Q-tips. And it's literally going to be just a case of getting as much of this. Look at that. Surprised there's any electrolyte left in any of them capacitors. Look, see that there? Disgusting. In fact, you don't need to see me do this, so I'll clean as much of this off as I can, and then we'll come back and we'll have a look. This is not going to be good. This is going to be really hard to fix. I mean, it might even be a case where it's just easier to put another power supply in here. We'll see what we can do though and keep it original. At least none of this has got onto the main board or anything like this. It is contained just in the power supply, and we'll have to have a look obviously when we get onto the rest of the thing, but I want a working power supply before we work on the rest of the computer, and then at least we can have a look at seeing about where we can get that to fire up. Anyway, I'll carry on cleaning and I'll come back once I've got this in a slightly bit of a better state, so back in a sec. Right, okay, I've brought you back. We can see here. Ugh, we've got those, and yeah, yeah. Yeah, that's just off the bottom of the PCB. You can see now that's looking quite a lot better. That's took a good half an hour of careful cleaning to get it that up to there, and it's still not right. I can still see traces of the electrolyte, and if I get my soldering iron and I bring it along like that and I have a smell, I can still smell it, so it's still on there. Really, what the best thing to clean this, honestly, would be an ultrasonic cleaning bath. I have one, but it's nowhere near big enough to even like get part of this, and it's tiny, mine. Very useful for doing small parts. It's actually designed for cleaning watches and stuff like that, but not much use for getting something big like this in. I will one day hopefully be able to invest in a decent ultrasonic cleaning tank. Right, all we've got really now is the muck and the leakage on this top section here, and to be honest, I'm thinking that most of this leakage has come from them two buggers there. What I'm going to do, I'm going to pull those off the board now, and actually, we've got the tester around here. We can actually see if they're still showing its capacitors or not. The 68,000 UF, they're actually Nichicon, but the 68,000 UF at 16 volts, I know for a fact I haven't got any of them in stock, so I'm going to have to order capacitors for this anyway. But there's no point in ordering capacitors until we've actually got this at least cleaned out a bit and see if there's anything horrifically wrong with it. Actually, to be fair, considering the amount of electrolyte that was on there, I can see a few tiny bits of corrosion. There, a little bit there, a little bit round here, a little bit there. That's it. With the amount of electrolyte that was all over here, I was actually expecting to see a lot of these traces a lot more badly damaged than they are. So we still stand a chance with this. Let's see if we can get those two capacitors off. Negative out that way, so we'll remember that just in case they aren't marked properly. This is going to absolutely stink. Oh, this stinks. Let me get some fresh solder. Oh, this really does stink. You have to bear in mind, this is stinking after I've done quite a bit of a clean up round here. It's affected that solder. That's why I'm adding a load of fresh solder onto them points. Hopefully I can get them to break free. That's coming out. Yeah. And I'm just walking the oh, look at that. Can you see all the leakage and the wetness on that capacitor there? It's actually soaking wet on the bottom. Let's get the other one out and we'll give these a really quick test if we can. Oh, that smell. That smell is disgusting. I don't even want to wipe my hair in where I normally wipe it. Ugh. Ugh. Get it off on there and that can go in the bin. So just because the capacitor's Nichicon, don't naturally assume it's going to be okay. Because I've found this a few times, especially in like Apple like Mac and Mac Classic and that era, some Apple monitors, Apple Macintosh SVJ monitors and things like that. I've used these Nichicon capacitors and I've found loads of leaky ones we're talking 80s, 90s era, these brown Nichicons. I think you usually find they're either alright or they've done that. So they do tend to leak these. Right, we've got them off the board. You can see here, ugh, all this is contamination from those leaking electrolytes. Let me get you down a bit so you can have a look. Ooh, wrong way. There we go. You can just see it all here, where it's all been spewing out, and obviously it really has got everywhere on this board. There's a little bit round here, not too much. Most of it actually seems to be limited to this area here, but that's where all the main power connectors are. There's an inductor there, that should be okay. Some power resistors, some switching transistors and probably voltage regs on there. That looks okay, that looks okay. It really does seem to be these particular Nishikons that seem to be troublesome. Right, let's have a spray around there. Let's see if we can get a load of this off. It is coming off, but you can see the amount of damage done. I have a feeling that actually around here must run quite warm. I mean, you've got a big heatsink there, you've got some big active components there. I wonder if it's the heat with having them two capacitors really close like that being baked. If you actually look at the board here, there is discoloration on the board, which is pretty indicative of the board getting warm, because these are Paxilin boards, you know, they're not fiberglass. That's what they tend to get used in power supplies, of these cheaper Paxilin boards, especially when it only has to be single-sided like this. And they show the heat up where they've got heat damages really easily. That's all this browning. If you look around the legs of that IC there, it's a double diode, a back-to-back double diode, judging by what's on the silk screen there. There's heat damage around the legs. There's heat damage around that resistor there. Really, to get in here, I'm going to have to basically strip all this part of the board off. And so just remember that the electrolyte is basically conductive, so and it's corrosive, so we've got to get it off the board if we could stand any chance of getting this this power supply working again. So what I'm going to do, I'm probably going to leave this video here for now. We've done the teardown, we've had a quick look inside it. I'm going to have to order some capacitors, because I know for a fact I haven't got any of them in stock. They're a bit bigger than what I normally have and what I normally use. So it being, what was it, 67? I think the biggest I've got are like 47,000 UF. I've got a couple of them. These are 68,000 UF. So I'll have to get some of those, and we'll have to carry on tidying up this board, and hopefully we might be able to get this working. If not, at least we know what all these do. They're all nicely marked on the board, what colours what. I mean, some are obvious, 5 volts, 12 volts and ground on them. 5 volts and ground there. Big grounds there, yellow. That'll be 12 volts, there'll be 5 volts. So it's only those two we really need to figure out, and one will be power good and then one will be minus 12 volts, I think. And then we should be able to use, we could even use an ATX power supply actually, it'd do. We'll have a hunt round, see what we've got, see what we could get to actually fit in that case and work. But first things first, let's see whether we can repair this one. I'll get those components ordered and we can take it from there. Anyway, so I'm going to leave it there for now. You've had a little bit of an introduction on this. At least we've seen it's not a complete basket case, with no major battery corrosion in there or anything. It's just a little bit dirty from obviously being stored not the best at some point in its life, but not the end of the world. Anyway, I'm going to leave it there for now. I hope you enjoyed this little introduction on this Amstrad 2286, and let's hopefully we can get it working. Hopefully we'll have a little bit better luck than we've had with getting old PCs working having the recent past. Anyway, I'll say thanks for watching and goodbye.